Hi there, great hands. Today we're going to be looking at angles that are bigger than 90 degrees. So we are working on the Cartesian plane. We are creating a unit circle just to kind of explore some ideas about trig. And then we're going to take this knowledge and put it to work where we're going to have to solve some problems. And it is important to understand these ideas, not just memorize the sums that we're supposed to solve. So what is a unit circle? Well, it's just that we're plotting points on the Cartesian plane and we're making the radius of the circle just one in order to show this concept. Obviously, it can be something other than one, but just for the sake of illustrating this idea, we're using a unit circle, so 1 unit radius circle, and we are moving around. So we're plotting that point and we're moving around. Maybe let me just do that for now. So we're plotting that point on the Cartesian plane with a radius of 1. So I can plot my point over there. Obviously, we will have an x value there and we will have a y value over there. And then very important, where are we now? We've just created an angle, a 37-degree angle, where we're starting with 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then 360. And then we've gone around, as we know, circle 360 degrees, and then we can go around again. This would be our quadrant 1, our quadrant 2, quadrant 3, and quadrant 4. And we'll do a summary of that in a moment. But there's something very important I just want to show you over here. So that means we are not just limited to acute angles anymore. I can create a triangle over there. When I have that point over there, I can create that triangle over there where I can use my trig ratios. So if I created an angle of 40 degrees over there, there is my opposite side. That is my opposite side, which must be that y value over there. Think about that. That must be our y value over there, our change in y. So it's the y of this coordinate over there. And then this one over here, my adjacent side, will be the x of whatever this point is. So take a moment and just think about that. All right, but now in this quadrant, we know that both the x and the y values will be positive. So it doesn't matter which trig ratio we're looking at, our sine, our cos, or our tan, they all will have positive ratios. Let's see what happens if we create a triangle in the second quadrant. So I'm going to create this exact same triangle in the second quadrant. How do I know that this is the exact same triangle, great heads? Because look at that angle that's forming over there. That angle of the other angle we formed in the first quadrant just now was a 40 degrees angle. So now look, if this is a 140-degree angle, we know that a straight line is 180 degrees. So if you use angles on a straight line, we know that that little acute angle that will form over there will also now be 40, because 140 plus 40 is equal to 180. So I just created a congruent triangle to what we just had in the first quadrant. But note what is happening to my trig ratios over there, great hands. My sine ratio is still positive. My cos ratio is negative. And if you put that into your calculators, you will see this. And my tan ratio is negative as well. Why is that? Because think about in this quadrant over here. There is my opposite side, which will still be a positive y value for that point. But think about this one over here, my adjacent side, my x value at that point. It will have a negative value. So that is why the ratios who makes use of our adjacent side, like our cos and our tan, the ratios will be negative. All right, so if you put into your calculator cos 40, it's going to give you a positive ratio because we're in the first quadrant. But if you put into your calculator cos 140, it's going to give you the same ratio, but it will be negative. And we'll do 2 examples like that just now, not interactively, but where you can grab your calculators and just check it with me. Let's go and create this exact same triangle in the third quadrant. So exact same triangle, meaning that that little acute angle over there must be 40 again. So we're going around, and it must be this one over here. There it is, the exact same triangle. How do I know that? Well, this theta, that angle over there, is now a reflex angle of 220. But this little acute angle over there must be 40, because think about it, there's our straight line 180, plus that 40 will give us 120. So that whole angle being 120. So I just created a congruent triangle in the third quadrant. But now have a look. Notice that now my sine ratio is actually negative. My cos ratio is negative, but my tan ratio is positive. Why is that? Well, if we form the triangle over here in this quadrant, then note that my adjacent side over there, my x value, is still going to be negative. But now my y value, my opposite side there, is going to be negative as well. So for our sine ratio, which is opposite over hypotenuse, which is always positive, that radius, will give me a negative because that one is negative. The purple one is negative, the y value. For cos is adjacent over hypotenuse, which my adjacent is negative divided by a positive will give me a negative. Let's think about tan. Tan is equal to opposite over adjacent. It's a negative divided by a negative x and y value, which will give us a negative divided by negative, which will give us a positive for our tan. So in this quadrant, your sine will have a negative ratio, your cos will have a negative ratio, and our tan would be positive. So if you put into your calculator sine 40, that acute angle that forms, it will give you a positive ratio for sine. But if you put into your calculator sine 220, it is actually going to give you a negative ratio. Let's create the exact same triangle in the fourth quadrant. It must be that one over there. How do I know that? It's because the full revolution, 360 degrees, and then if I want a 40-degree angle over there, 360 minus 40 gives me that 320 degrees. So I created a congruent triangle over there. Notice that all the trig ratio stays the same. It's just the signs that change. Cos is positive there. Why? Because there my x value is positive and my opposite, my y value, is negative in this quadrant. So why is sine negative? Because my opposite is negative over my positive, which gives me a negative. Why is my cos positive? Because it is adjacent, my x value, which is positive, over r, which is positive. Why is my tan ratio negative? Because tan is equal to opposite, negative, divided by adjacent, positive. So that will give me a negative ratio. And there we go. So notice as I move it around, in the first quadrant, all my ratios are positive. In the second quadrant, cos and tan are negative. The only one that's positive is sine. In the third quadrant, sine and cos are negative, but tan is positive. And then in the fourth quadrant, cos is the only ratio that is positive.